11s, we have to carry on with the work. We did in the previous period, we had a look at the making of salts. Alright? 3 methods. The one is a soluble acid and a base. The next one was an acid plus an insoluble base, and the third method was using 2 insoluble salts. 2 soluble salts, we add them together, it makes an insoluble salt. Okay, now I don't want to say more about that. The next section that we must have a look at then has got to do with the identification of the different ions. Now, we divided up into different sections. The first section is the positive ions. What's another word for a positive ion? Is the cat or an ion? It's a cat ion. It's an anion. Okay, an anion is attracted to the anode, and the anode is positive. No, so no, it's a cat ion. Seriously. Okay. The what? Yeah. Okay, and when you get a cathode, there's also a T, but a cathode is negative. Okay, people, in general, the cations are the metal ions. Okay. Now, we are going to have a look then at it's actually got to do with the colors of these ions when we sort of force them to form insoluble salts or solutions. Now, in your textbooks on page 86, there's a very important part, and you tend to not read it. Alright? So right at the bottom of page 86, there's a heading, the chemistry behind the tests, and then dash cations. I want to read the section. They say, when you carry out the test for the cations, okay, the cations are the metal ions mostly. Ammonium is also a cation. Okay. You will make the metal hydroxide. Why? Most metal hydroxides are insoluble. Alright. And those of transition metals are colored. Alright, so the color of the precipitate would therefore tell us which metal we have. Right, now on the next page there is a table of the different metal ions that we must be able to test for. Now on page 87 we have got aluminium. We've got calcium, and we've got zinc, and there's a reason why I write them like that, next to each other. Then we will test for copper and iron. Copper 2 plus, aluminium is 3 plus, calcium is 2 plus, zinc is 2 plus. We are going to test for copper 2 plus ions. We are going to test for copper 2 and for copper 3. Ions, ione. Iron 2 and iron 3. Alright. When we test for metal ions, that sentence that we've just read, we need to make a hydroxide, because most of the hydroxides are insoluble. So how will I make a hydroxide? We've just done making of salts. We add 2 soluble salts together, and we can make an insoluble salt. Okay, so I must add something to this. For example, if I have copper chloride in solution, to the copper chloride I can add sodium hydroxide. These are 2 soluble salts, and I will get copper hydroxide, which is insoluble. Do you understand? Alright, now the same thing happens with all of the metal ions. So the first reagent that I use to test for my metal ions would be to add a few drops of sodium hydroxide. There's a reason why it's a few drops, okay? we find that sometimes, not with all of them, if I add a few drops, it immediately makes an insoluble salt. The insoluble salt you can see because it becomes murky. You can't see through the solution anymore. And if you left it to stand overnight, the next morning there will be a powder in the bottom of the test tube that you can filter out. Okay? That's not white. Copper is blue. It's not necessarily white. There is a powder left. Yes, a solid is formed. Well, that is the precipitate. That's the insoluble salt. The hydroxide. The metal hydroxide. Okay? Different metals have different colors. But this stuff then is the precipitate. And the color of that precipitate indicates what metal I have. When you add a few drops of sodium hydroxide, we make the insoluble salt. Now, when you add excess, what does excess mean? Lots of it. Okay, I will fill up the test tube with it. Then we sometimes find, not by all of them, but that something special happens, and what is formed is called a complex ion, which is soluble. In other words, then this precipitate suddenly disappears. Okay, but I'll come back to the complex ions that are formed a little bit later on. If I add sodium hydroxide to a solution containing copper ions, I will get a copper hydroxide precipitate. And it's blue in color, light blue. Okay? So what's the color of copper sulfate? Blue. Alright, it's a similar color blue that we are talking about, light blue. If I add a couple of drops of sodium hydroxide to iron 2, I will get iron, come on. Alright, copper hydroxide, I will get an iron hydroxide, which is green in color. Alright? And if I have got iron 3 ions in solution, and I add sodium hydroxide to it, I will get a red precipitate. Yeah, a red-brown. Okay? What's the color of rust? Rust is iron 3. Yes. But it's the iron 3 plus iron. Whether it's the oxide or the hydroxide, the iron 3 plus iron is red, reddish brown. Well, yes. If the oxide that is formed is green, then it's iron 2 oxide that has formed. Yes. But that could be a deposition of other salts as well. Okay. But in general, iron 2 is green, iron 3 is red. Now, how are you going to remember that? Well, iron 2 is green, and green has got 2 E's. Yeah. Iron 3 is red, and red has got 3 letters, so don't confuse it. Okay? Those are the only 3 colors that you must remember for the metal salts. Copper is blue, iron 2 is green, and iron 3 is red. The others over here will form aluminium hydroxide, calcium hydroxide, and zinc hydroxide, and they, unfortunately, are all white. No. Okay, now, so if you get a white salt, then you can know it's either aluminium, calcium, or zinc. You with me? So there's a second step. Okay? Just have a look. Go to your notes, your textbooks. They start off at the top of page 87. For aluminium, add 2 drops of sodium hydroxide, a white precipitate will form. For zinc, add 2 drops of sodium hydroxide, a white precipitate will form. For calcium, 2 drops of sodium, a white precipitate will form. Are you with me? Now, the second step, we now go and add excess sodium hydroxide. We find that A to Z will disappear in excess. Calcium will remain. So, I've got my test tube. I've put a few drops of sodium hydroxide into it. I get a white precipitate. I must immediately know I've either got aluminium, calcium, or zinc. So now the second step is to add excess sodium hydroxide. So I fill up the test tube. If the precipitate remains, we've got calcium. If the precipitate disappears, it becomes soluble, we've got either aluminium or zinc. All right. Now, I'll come back to distinguishing between aluminium and zinc. We have got aluminium, calcium, zinc. Then we've got copper, we've got iron, and we've got iron. All right. Now, the first set of tests, we used what as a reagent? Sodium hydroxide. Now, there's a second set of tests that we can use. The reagent that we will use is ammonia solution. Now, ammonia solution, ammonia, if I dissolve it in water, it forms ammonium hydroxide. So the reagent that we are going to be testing with is actually ammonium hydroxide. It's a hydroxide. Okay, so if I add a couple of drops of ammonium hydroxide, what will I get by copper? A light blue precipitate. What will I get with iron 2? A green precipitate. What will I get with iron 3? A red precipitate. And what will I get over here? A white precipitate. Okay, go back to your notes. I'm busy with aluminium, zinc, and calcium. They say by zinc, by calcium and aluminium, they only refer to sodium hydroxide. All right? But it will form a white precipitate with ammonium hydroxide, a few drops. If you go and read by zinc, they say add 2 drops of ammonium hydroxide, you will get a white precipitate. And when you add excess ammonium hydroxide, what's going to happen? The zinc is soluble. This one is soluble in excess ammonium hydroxide. All right. Remember with the first test, aluminium and zinc dissolves. Calcium remains. So we've sorted calcium from that equation. So if I have a test tube and I don't know whether it's aluminium or zinc, what am I going to use? Ammonium hydroxide, because aluminium is going to make a white precipitate that is going to stay. And zinc is going to make a precipitate that's going to disappear. Yeah. Yes. 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 Then you know you've got calcium.
Okay. Maar as dit moes nou disappear, dan dit moes nou aluminium of zinc.
Yes.
Nee. Nou as jy daai ding vat met die sodium hydroxide en dan mag jy
No, you must make a fresh solution. You start off with a fresh iron solution. Yes, yes.
Okay, so as jy nou maar dan sê ek hoe moet jy dit uitwerk?
Well, you will set up 2 test tubes with aluminium, 2 with zinc, 2 with calcium. So in the first set of test tubes, you add the sodium hydroxide. You get the white precipitate. Disappears or doesn't disappear, you want to confirm. You use the second set of test tubes. Do you understand? And you start with ammonium hydroxide. Okay? No, no. You must start with a fresh solution in a new test tube. No, not always, because then the zinc is going to be... It just forms a white precipitate. It doesn't disappear. Slightly all white. In actual fact, the calcium forms a slight all white precipitate. It's not at all. You have to do both steps if you want to sort out those three. Okay. Okay, now, when we go and have a look at the metal ions with ammonium hydroxide, we said we get the light blue precipitate, we get the green precipitate, and we get the red precipitate. Here by copper, there's something extra that happens. If I go and add excess to all of them, the green precipitate will remain, the red precipitate will remain. But the light blue precipitate of copper, if I add excess ammonium hydroxide, it forms the ammoniated complex ion, which is a deep dark blue solution. All right. About the color of your shirt. That is the metal ions. Okay. Now I'm going to stop there because I've got a video clip somewhere that I will show you. Okay.
Great combo deal from Choppies. Top Score maize meal 10 kilograms, Buck Pro Fed Cook flour 10 kilograms, Banana Elbow 3 kilograms, Rice King 10 kilograms, Sugar King 5 kilograms, white or brown sugar, and Polana 1 kilogram spaghetti for only $499.95. Choppies, great value for your money.
We had a look yesterday at the test for metals, metal ions, the cations, okay? And the reagents that we used to test the metal ions were, first of all, sodium hydroxide, and then there was a second set of tests that we used ammonium hydroxide. And in each case, we found that we got a precipitate or no precipitate. Okay? The first metals that we had a look at was aluminium, calcium, zinc. Then we had copper, iron, 3 plus, 2 plus, 2 plus, 2 plus, 2 plus, 3 plus. All right. We found that with sodium hydroxide, with these three, if you add a few drops, we got a white precipitate. On adding excess, we said calcium persists, but aluminium and zinc becomes soluble. All right. We said copper gives a light blue precipitate. Iron 2, we said gives a green precipitate, and iron 3 gives us a red, yeah, precipitate, or in brackets solid. Yeah, okay, sometimes they use this like that. Alright, then we said there's a second set of tests that we can do because this test does not distinguish between aluminium and zinc. Okay, so to distinguish between aluminium and zinc, we will get a white precipitate. On excess, which one dissolves? Okay. Then with the rest, we got a light blue precipitate, a green precipitate, and a red precipitate. Although here by the copper, on adding excess, what did we get? Dark blue solution. Alright, in other words, the precipitate becomes soluble. Now people, you need to know these tests, okay? There's no way around this. On paper 3 for the ordinary level, they give you a table with this information. Higher level, when you do practical and you need to do testing for ions, they give you the chart with the tests on it. But for paper 1 and paper 2, you need to know these tests. And they do ask the questions. Alright? Yeah. Because paper 3, the alternative to practical and practical, does not test root learning work. It tests a different skill. Okay? So you need to know this. You have to go and learn this. Okay, now. Yeah. Okay, the next thing that we have to have a look at is the anions. Now the anions are negative ions, and the ones that we must have a look at is carbonate and sulfate and iodide and nitrate. Is there chloride as well? Yes, chloride as well. Let's do it over there. Okay. Please, people, take note the difference between chloride and chlorine. There's a difference. The one is the ion. It's usually soluble. The other one is the element, which is often not soluble in water. The chloride is the ion, yes. Alright. The chlorine is the diatomic element. So, we are testing for the ions. Alright. Now, I'm going to start off with the carbonate. Yeah.
Cations are the metal ions.
Yes. Yeah, usually the non-metal ions, yes. No, there isn't an exception. Alright. People, test for carbonate is actually sort of indirect. We know that if we take an acid plus a carbonate, we will get a salt plus water plus carbon dioxide. How do we test for carbon dioxide? Bubble the gas through clear lime water. If the water turns milky, it is carbon dioxide. So, how do we test for carbonates? Well, we will add an acid to the carbonate. And it's going to fizz. It's going to bubble. There's going to be effervescence. So the moment you see that, you have to catch up the gas, and you have to test the gas to see whether it will turn clear lime water milky. Will you bother testing it with a splint? No. Because some gases will make a splint die, others, like hydrogen, can also make it pop. Okay, it depends a little bit. So we are going to specifically test to see is there carbon dioxide, because if there is, then we've got a carbonate. If there isn't, we didn't have a carbonate. Do you understand? It is slightly more dense than air. Okay. when I catch up the carbon dioxide, this is very important. If I want to catch up hydrogen, you've seen the diagram, we go and bubble the gas. We've got water here, okay, and as the gas bubbles up, are you with me? It pushes the water down. We talk about the downwards displacement of water. Can I catch up carbon dioxide with a downwards displacement of water? It's water soluble. So I would catch up carbon dioxide. It's just much easier. I take a cylinder and I put the gas in there, and the carbon dioxide will go to the top, and what is going to be pushed out? Air. The upwards displacement of air can be used to catch up carbon dioxide.
Or you could just straight put it in the beaker.
Yes, yes. Or you can just simply, on the container, and this is usually how we do it, you'll do it in a conical flask, you'll put a stopper in it, alright, with a tube, and it will deliver it directly into clear lime water. You'll bubble it through. If it becomes milky, we've got a carbonate. Because it's hot, due to burning, combustion, hot gases rise. Yes, but then it gets trapped due to temperature inversion in a layer in the air. Okay? Yeah. That's why it causes a problem. It shouldn't be there. Or not as much of it should be there. A little bit must be there because it's the greenhouse effect that keeps the temperatures moderate, but it's becoming too much. Okay, so the test for carbonate. Add an acid, test the gas with clear lime water. If it turns milky, we've got a carbonate. So in your textbooks, they've got there, add dilute acid, test the gas evolved with lime water. The result, lime water turns milky. Okay, now, the test for sulfate, you will see that many of these tests, they add a couple of drops of nitric acid. The reason for this is that's with the test with the chlorides and the iodides as well. All nitrates are soluble. So sometimes if there is an impurity, the nitric acid that you've added will keep the impurities, the tiny amounts, out of the test so it doesn't confuse the test. So very often the test starts with acidify with a couple of drops of nitric acid. No, because it's going to fizz. Okay. Then to test for a sulfate, we will add barium chloride, or barium nitrate will also work. Okay? Barium chloride, a soluble barium salt. Okay? Because what happens is most of my sulfates that you will work with are water soluble. And the moment the barium is added, we make barium sulfate, which is a white precipitate. So the moment you must test for sulfate, it doesn't matter what sulfate you are testing for, calcium sulfate, hydrogen sulfate, sodium sulfate, aluminium sulfate, it doesn't matter. The moment you test for sulfate, the SO4 ion, you add barium ions to it, a soluble barium, because the barium sulfate that is formed is insoluble. And it's a white precipitate. And it's very clear, it's not obscure. All right. All right. In your textbooks, they say add 2 drops of hydrochloric acid, dilute hydrochloric acid, followed by 2 drops of barium chloride. You will get a white precipitate. Yeah, it doesn't really matter. Okay. Then, the chloride and the iodide. For the chloride, they say add 2 drops of dilute nitric acid. For the iodide, add 2 drops